Have you ever wondered what it looks like when a giant star dies? We're not talking about a peaceful fade to black. We're talking about a supernova, one of the most violent and spectacular events in the entire universe. For decades, scientists have theorized about these cosmic fireworks, but seeing one happen in real time, right from the beginning, that's been a bit of a mystery until now. Imagine this: a star 15 times more massive than our own sun suddenly collapses and explodes. It's an event of unimaginable power, but it happens so fast that catching the first moments has been nearly impossible. But recently, a team of scientists got incredibly lucky. Thanks to some quick thinking and the power of the European Southern Observatory, a very large telescope in Chile, they managed to witness the birth of a supernova just hours after it began. The discovery happened on April 10th, 2024, just as astrophysicist Yi Yang was landing in San Francisco after a long flight. Alerts about a new supernova started buzzing. This star, located 22 million light years away in a galaxy called NGC 3621, was going critical. Yang didn't waste a second. He immediately submitted a request to point one of the most powerful telescopes on Earth at this brand new explosion. His request was granted, and just 26 hours after the initial detection, the telescope was locked on, capturing data that would change our understanding of how stars die. So what did they see? Did the star just blow up in a perfect fiery sphere like we often see in animations? Not at all. What they saw was much more interesting. The star, a massive red supergiant with a diameter 600 times that of our sun, was already surrounded by a disk of gas and dust around its equator. When the explosion happened, it didn't expand uniformly. Instead, the blast pushed violently outward from the star's poles on opposite sides. This squeezed and distorted the explosion, shaping it into something that looked, well, like an olive standing on its end, a giant, cosmic, exploding olive. This unique shape is a huge clue for scientists. It tells them about the physical processes happening deep inside the star's core right before it detonates. For years, the exact mechanism behind these explosions has been a hot topic of debate. How does the core collapse trigger such a massive outward blast? The olive shape they observed actually rules out some of the popular scientific models. It suggests the explosion isn't a chaotic, random event, but a structured one, possibly guided by the star's rotation or magnetic fields. This observation was possible because they caught the supernova during a very specific, fleeting moment called the breakout. This is when the shockwave from the collapsing core finally bursts through the star's surface. In that short window, before the expanding cloud of debris gets too big and messy, the initial shape of the explosion is revealed. It's like getting a blueprint of the cataclysm itself. The star in question was about 25 million years old. That might sound ancient, but for a star this massive, it's a short and fast life. Our sun, by comparison, is over 4.5 billion years old and is only middle-aged. After the star's explosive finale, what's left behind? Scientists believe the core collapsed into a neutron star, an incredibly dense object where a teaspoon of its material would weigh billions of tons. This incredible discovery is more than just a cool picture. It's a fundamental piece of the puzzle that helps us understand stellar evolution, the creation of heavy elements, and the very structure of our universe. By seeing a supernova's first steps, scientists can refine their theories and get closer to solving one of the biggest mysteries in astrophysics. It's a reminder that even from 22 million light years away, the universe can still show us something brand new and utterly astonishing. Thanks for watching. If you love learning about the mind-blowing wonders of space, make sure to like this video and subscribe for more deep dives into the cosmos. See you next time.